So 3.4, B as in boy, college algebra, page 291. We're starting with the section titled Zeros of Polynomial Functions with Real Coefficients. So what they're saying is that if we have a polynomial function that has real number coefficients, like what I have there, so we've got a 1 there, a negative 2 there, and a positive 2 there. If we have real number coefficients, and if we find out that one of its zeros is like 1 plus I, so if we find out that that's one of our solutions is 1 plus I, okay, and that isn't just a factor, that is a solution, okay, that is one of the roots. So if 1 plus I works, then its conjugate also works. So when you find one factor, or one root, you've actually found a second root. So just something to keep in mind there when you're doing these. It kind of gives you a free one. So keep in mind that the coefficients are real numbers, which means they could be pi, it could be a square root, as long as it's a real number. It doesn't have to actually be a number like 2. It could be a radical or pi. And another important thing to realize is top of page 292, if we have irrational zeros. So let's say that you're doing one of these problems and you get as one of your zeros or one of your answers 1 minus the square root of 3. Well, if 1 minus the square root of 3 works, so does 1 plus the square root of 3. Again, its conjugate will work. So let's say that we have a polynomial function with a degree of 6, and it gets coefficient with rational coefficients, and it gives you 3 of its zeros. So out of the 6 zeros, it gives you 3 of them. That one, and that one. Okay, and we know there's 6 because it says it has a degree of 6. So we know that there's at most 6. So, according to what we just went over, the 2 plus 5i also has its conjugate is one of the roots. 2i, which is actually 2 minus or 0 minus 2i. So that being the case, it would be 0 minus 2i, which is what we have, and 0 plus 2i, and 1 plus the square root of 3. So there are all 6 of my roots if I have a polynomial function that has as a degree 6. Alright, let's look at example 4, middle of page 292. And it says find a polynomial function of lowest degree with rational coefficients that has 1 minus the square root of 2 as one of its zeros, and 1 plus 2i is one of its zeros. Okay? So, let's see what we can do here. So we know that another one of the zeros is that, and another one is that. And it asked for the lowest degree. So this is the least number of factors that we can have. So now what we do is we take our answers and write them as, this is the least number of solutions we can have. Now we're going to take these solutions and make them as factors. So remember before I said that if we have an x minus c, that is the formula for every one of the factors. So x minus c times x minus another number times x minus another number, etc. So that's what we're going to do here, is we're going to write these roots that I have up here, each of these 4 roots, as factors. So I'm going to have to write x minus c. Well, what is c? It's this whole thing here. And then x minus this whole thing, then x minus this whole thing, and then x minus this whole thing. So it's going to look really weird. It's going to be, do it here in blue here, f of x equals x minus 1 minus the square root of 2, because that 1 minus the square root of 2 is my c, times x minus 1 plus the square root of 2 times x minus 1 plus 2i times, and we'll continue down here, x minus 1 minus 2i. So those are my four factors. But what in the world do I do with those four factors? Well, let's see what we can figure out here. I'm going to move these up here, and I'm going to take my x minus 1 minus 2 and get x minus 1 minus or plus the square root of 2. So I took the radical sign off. I'm sorry, not the radical sign, but the parenthesis here and here, and because that's a minus, that becomes x minus 1 plus the square root of 2. Okay, and then I'm going to multiply that by, again, take off the parentheses, and that becomes minus square root of 2, times, again, take off the parentheses, and then the bottom one, x minus 1 plus 2i. Now I've got to multiply all of these. So I'm going to multiply this one, and then multiply that times this, and multiply that times this. So this becomes quite a mess. I'll let you do all that multiplication, because when they do that, they get an answer of x to the fourth minus 4x cubed plus 8x squared minus 8x minus 5. So this answer that I've got in the bread box here is the polynomial function given those four zeros that were given to you in example 4 in the instructions there. Okay, so then you just do the FOIL method and you end up with the original polynomial. So if somebody said, can you factor this polynomial down for me into its factors and then find its roots? And you can say, sure can, and you just go backwards there. So anyway, that is example 4. So let's continue on with integer coefficients and the rational zeros theorem. So bottom of page 292, integer coefficients and the rational zeros theorem. Now, if you remember, when we talked earlier, we said that, if we've got a function, a polynomial function, and it looks something like this, 3x to the fourth minus 11x cubed plus 10x minus 4. And let's say what I want to do with this is I want to find the zeros, or the factors first, and then the zeros. So if you remember, we did synthetic division. So that was in order to find out what my factors are, what goes evenly into this with a zero remainder. And what we'd done before is just kind of grabbing numbers and say, well, gosh, let's try 1. Let's do the synthetic division, see if 1 is a root, and then I know that x minus 1 would be a factor of this. And then try 2 and 3 and 0, negative 1, negative 2, negative 3. I mean, just go on and on and on. You're just kind of guessing on what numbers to plug in to see if they're going to be factors, and that could take all day. So there is another method of doing this called the rational zeros theorem, and that's what we're going to do in order to solve this. So what we're going to do is we're going to use a rational number, and we're going to call it P over Q. Okay. And the way this rule goes is if this rational number, P over Q, a number over another number, if P over Q is a factor of our polynomial function, then we've got one of our factors. So that sounds kind of duh, but let's look at this. I guess I should say if P is a factor of this and Q is a factor of that, then if we write it as P over Q, so for example, if let's say P is a factor of -4, so one of the factors of -4 is 2, okay? 2 times 2 is 4. So if that works, and we take one of our factors of 3, which in this case you have 2, 3, and 1, we put a 3 here. If 2/3 is a 0, or then 2/3 will be a 0 of this here. Okay, so let's just try one, and we'll try to make sense of this. The way I explained it probably isn't helping you a whole lot, so let's just look at it. Alright, so what we're going to do here in order to solve this is we're going to look at the factors of P first of all, which again is the last number. So I'm trying to find numbers multiplied together that give me -4. Okay, plus or minus 1, plus or minus 2, and plus or minus 4. Okay, those are my factors, because I could take a +1 times a -4, a +4 times a -1, a +2 times a +2, a -2 times a negative, or I'm sorry, a +2 times a -2, and a -2 times a +2. Anyway, so I get, those are my factors for 4. If I look at my factors for 3, my Q, I get a plus or minus 1 and a plus or minus 3. Those are my options. Okay. So if I were to put these in reduced form, I would have +1 over +1, which is 1. -1 over -1 is also 1. +1 over -1 is -1, or -1 over +1 is -1. So just using these, I get these options. Okay, if I were to just take those fractions. Okay, so let's use the 2. So I'm going to look at the 2's with the 1 and then the 2's with 3's. So I get a 2, -2, I get a 2/3, and I get a -2/3. If I look at my 1's with my 3's, which I didn't do yet, I get a 1/3 and a negative, and you'll see why I'm doing this in a minute, -1/3. Okay, now let's use the 4's. So I've got to do the 4 and the 1 and get a +4 and a -4, and then I've got to do the 4 with the 3, and I get a 4/3 and a -4/3. Okay, so those are the possibilities for P over Q. And what I've said though, as far as P over Q is, if we have P and Q and they're prime numbers, and they are factors of my 3 and my -4, my first coefficient and my last constant, if P over Q is a 0 of this whole thing, then P is a factor of, let me get my pointer here, and Q is a factor of here. So to say that the other way, if I take the factors of P over the factors of Q and write them all out, these end up being my zeros to this problem here. Okay, so rather than having an infinite number of solutions to go through to find out which ones, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers to use synthetic division for in order to find out what my zeros are. So, here's the method to do this. We're going to pick the easiest numbers to do synthetic division first, because again, we only have 4 answers here, and I have 12 different possibilities. So I want to try my whole numbers here before I start messing with fractions. Because if I can find my zeros within my whole numbers, that is going to be a lot easier than starting out in my fractions. So I try 1. And when I try 1 using synthetic division, I have, let's see, a 3, negative 11, a 10, or a 0. Let me get rid of that and put a real 0 in there. A 0, a 10, and a negative 4. And the book does something, and I kind of like what they do here, is they make a little block there to show that this is where my remainder is going to be. Okay, so we bring down the 3, 3, negative 8, negative 8, negative 8, negative 8, 2, 2, negative 2. Okay, so 1 doesn't work. We get a remainder. So we go and work on the number 1. And this is where things are going to get a little bit easier, but hopefully not tricky. So let's try negative 1. And again, we have 3, negative 11, 0, 10, negative 4. So 3, negative 14, positive 14, positive 14, negative 14, negative 4, positive 4, 0. So I know that x plus 1 is a factor. Okay? Not only do I know x plus 1 is a factor, but I know what I have left is 3x cubed minus 14x squared plus 14x minus 4. I know I have that left. Okay, so what that tells me is that this is also a factor of this up here, which means the factors of this are also going to be factors of this. So what happens is I don't have to go back and do synthetic division on this one anymore. I can do synthetic division on this one. And the reason I would do it on this one is because my exponents are smaller, which means it's going to work out easier for me. So when you find a factor, start doing the synthetic division on this here. So the numbers I'm going to try to divide into this using synthetic division are the rest of them I have here. So I tried the 1 and it didn't work. I tried the negative 1 and it did work. Now I'm going to try my 2, negative 0, 4, negative 4, etc., on this factor. It's going to be easier, I promise, if you use this one instead of this one up here. So let's go ahead and try that. So when we try, let's see, what else was on that list? We had a 2, we had a negative 2, we had a 4, and we had a negative 4. And let's just suffice it to say that none of those gave you zeros. When you did the synthetic division, we found out those did not work either, which means that leaves us, we're stuck with doing fractions. So let's try 2/3. So let's put a 2/3 here, and we'll do a 3, a negative 14, a positive 14, and a negative 4. Bring down the 3, we get 6/3, which is 2. Add those together, multiply, negative 8. Add those, we get 6. Multiply, we get 4. Remainder is 0. So 2/3 does work. So we have x plus 1. We have x minus 2/3. And what we have left is 3x squared minus 12x plus 6. Okay, so we're whittling this down. So rather than doing synthetic division, let's do some reducing here. So we've got x plus 1, x minus 2/3. I'm going to factor out a 3, like that, and then I cannot factor that, so I'm going to use quadratic formula. And what's going to happen is when I use quadratic formula, I'm going to get a little bit nasty of an answer here, but let's put it down here anyway. So let's move the 3 to the front. X plus 1, x minus 2/3. And when you use the quadratic formula, you got, for this, you got your values of 2 plus or minus the square root of 2. Okay? So, for the rest of this, I got x minus 2 minus the square root of 2. And then I'm going to get x minus 2 plus the square root of 2. So what I have here at the end, this 1, 2, 3, 4 factors. And we started out with an x to the 4th power, so we would expect to get 4 zeros. Okay? So again, my zeros are -1, positive 2/3, 2 minus the square root of 2, 2 plus the square root of 2. So these are my factors, and my roots are the single digits that make each one of these equal to 0. Okay, so that's example 5.